Well, welcome to this online revision session for AQA M2, in which we'll be looking at the June 2011 question 5 on power. Quite a short question, this one. We have an engine with 5 carriages. There's a constant resistive force of 3000 newtons on the engine, and on each of the carriages 400 newtons. The maximum speed of the train is 90 kilometers per hour. So, first part says show that the speed is 25 meters per second. So we've got to convert the 90 kilometers per hour to 25 meters per second, or show that's what it will become. So the 90 kilometers per hour will be equal to, well, what have we got to do with the 90? Well, to convert it into meters we've got to multiply it by 1000. And then to change the hours into seconds, we've got to divide it by 3,600. That's 60 times 60. And from there it's just a straightforward calculation, which will give us 25 meters per second. 1 mark for showing the necessary calculation that's required. Okay. Part B then says, hence find the maximum output of the engine. Well, the maximum output will be when it's doing its maximum speed. Now we know that the power output is equal to the force times the speed. Now the force in this case must be sufficient to overcome the resistance of the engine and the coaches or carriages. So this force must be equal to 3000 plus 5 lots of 400, because there's that resistance on each of those coaches. So the total resistance on the train is 5000 newtons. So therefore we need that to be the driving force to keep the train moving at its maximum speed, i.e. when it's in an equilibrium, that the driving force must be equal to the resistive force so that they're in equilibrium. So this then, to give us the power, must therefore be 5000 multiplied by the speed of the train, which is 25, which is going to give us an answer of 125,000, and that will be in watts. We want the answer in kilowatts, so we've got to divide that by 1000 to give us 125 kilowatts. Okay, 3 marks for that, stating what the total resistive force is and hence what the driving force must be. I'll give you 1 mark. Appropriate calculation being carried out here will be 1 mark. And then an accuracy mark for obtaining the 125 kilowatts. It must be in kilowatts to get that additional mark. Well, hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.